All right. Hello, everyone. In O level, and also for students who completed IGCSE physics, you already learned how to combine similar vector quantities like two or more displacements, velocities, or two or more forces, and many others. Say we have a vector, a velocity as an example. For example, this one, this arrow, represented by this arrow. Here, let's say the magnitude is around 18 meters per second, and the direction angle is around 56 north of east. Okay, now this object having this velocity, we can imagine that this is a boat, and the boat is having this velocity. All right, 18 meter per second, around 56 degrees north of east. Okay. Now, also imagine that the current in the river, for example, is another vector. Of course, the velocity is say let's represent it with this arrow B. All right. The velocity is say um, around 21 meter per second, and the direction of the flow of the river is 14 degrees north of east also. The resulting velocity, a resultant vector, in this example, call it a resultant velocity of the boat. You know that by graphical method, it is this arrow C here. All right. Let's put arrow C here. This is the representation or the arrow representing the combined velocity of the boat itself and the river. Okay. And in the end, this is going to be the velocity of the boat. Let me just clarify this vector A here. This is the velocity of the boat when the um, river is not flowing. But because the river is flowing at a certain velocity also, then the boat will be having a resultant velocity which is being represented by this arrow C here. Now, if these arrows are drawn in scale, then you can determine the resultant velocity already. That is what you were doing when you were in O level and IGCSE physics. However, it is sometimes more convenient for students sitting for an external physics exam to use the analytic or mathematical method as it is faster. And as you know, you are allowed by Cambridge International to use scientific calculator during exams. All right. With this analytic method, when adding the resultant vector or the result of adding these quantities here, A and B, we consider this right triangle here. All right, let me show it to you. All right, this right triangle here. Okay, this area that I'm shading, and this right triangle here having this side and this side also. And if you know the magnitude of these sides, then it's going to be very easy for you to calculate the hypotenuse of the right triangle, which is the magnitude of our resultant vector. It's relative to the angle theta here. We call this adjacent side relative to this angle. We call this opposite side relative to this angle also. Now, in order for us to determine the length of the sides of the bigger triangle here, then we just add all the components. For example, this part here, okay, if we're going to put this here and this one here, all right, as you can see, this magnitude along the vertical of vector A added to the magnitude of uh, vector B along the vertical is going to give you the opposite side of the bigger right triangle that I showed to you a while ago. In equation form, in calculating the component of the vector C along the vertical, which is Cy, this is simply the component of vector A along the vertical, which is represented by this blue line, all right, plus the component of vector B along the vertical also represented by this green line. And AY can further be calculated using this formula involving cosine here. AY is equal to A sine theta. All right, calculating this part here, where the angle is this one, okay, the direction angle of vector A, or the velocity A, all right? Now for the other vector, vector B, the component can be calculated by using this one, multiplying the magnitude of this velocity, sine of the direction angle, all right, which is this. Okay. Now for the other side of the triangle that we need to calculate the vector C, or the resultant vector, we can move this here again. All right, we can move this back again here, and then move this around here, so we can easily see this part here. Okay, the magnitude along the horizontal of vector B, when added to the magnitude of vector A along the horizontal, will give you this side of the triangle that we need to use in calculating the vector C. All right. Based from this, you can easily see that the component along the x-axis of the bigger triangle is equal to the sum of the component along x of the vector A, which is represented by this blue, and the component along x, or along the horizontal, of the other vector B. All right. And just like what we did a while ago, we can also calculate that one given the magnitude of the vector A and the direction angle. All right. Same is true with this. The component of the vector B along the x-axis can be calculated with that. All right. And the angles here are the direction angles. All right. This is the direction angle of vector B, and this is the direction angle of vector A. All right. Now, in the end, what will happen is that we can just remove this one, all right, so that our skin is not very messy, all right. So we can concentrate on this big triangle. Assuming that you have already calculated this side, the c sub x, which is the horizontal component of the resultant vector, in our case here, resultant velocity. And this side here, assuming that you also calculated this one based from the earlier formula, C sub y means vertical component of our resultant. All right. Now, in order for you to calculate this, which is the magnitude of the resultant vector C, you can use the Pythagorean theorem. All right. As usually, people will use the modulus sign just to imply that we are after the magnitude of a certain vector only. All right. In our case here, we have a right triangle, and using the Pythagorean theorem, we can have this equation. All right. You use this in determining the magnitude of the resultant vector. All right. Now for the direction angle, which is this one, you can use the arctangent of the opposite over the adjacent, which is the magnitude of the opposite side, which is this, the cy, divided by the magnitude of the horizontal component, which is the cx. All right. So this is the analytic method in determining two or more vector quantities. All right. In our case here, we use velocities, but the idea also applies to any other vectors that we know. All right. Forces, displacements, accelerations, and many others. Okay. Bye.